Welcome back to Area Diesel Service. So today we're going to bring you some new collaborative content with fellow YouTube creator CNC Equipment. So if you haven't come to this video from Clinton's channel, the situation is they've got a 2003 John Deere 550H Bulldozer in, and they're doing their standard go through, clean up and resale process, and the pump on this machine was leaking fuel. So
what was going on? It's leaking. I think the front seal is leaking. It's actually dumping oil into the engine now, or fuel into the engine, isn't it? So that's why I was taking it apart. I probably could have fixed that seal, but like I said, Area Diesel knows what they're doing, and these things are prone to go bad about 5,000 or 6,000 hours. So
Clinton reached out and said, hey, I've got this pump. Do you guys have these in stock, or do you repair them? And the answer was yes, both, absolutely. We do a fair amount of these pumps. This particular dozer has a John Deere 4045 engine, 4-cylinder. It's about an 80 horsepower turbocharged John Deere diesel engine, and this particular unit has about 5,500 hours. 5,500 hours on this particular pump is pretty good. We're going to call that lifespan. While this pump is still running good, running correctly, it has developed a fuel leak, and that is the primary mode of failure from these DE style Stanadyne pumps. Alright, so we haven't seen Clinton's pump yet, so we're going to open up this box and have a look. So these guys always do a great job of getting this stuff packed up and sent over. First thing, contact information. It's always good to know who the pump has come from. It's got some packing peanuts. Got it packed up nicely. It's always nice to see somebody take some time to package them. We get a lot of pumps in for repair work that are damaged in transit, even on top of the existing damage or reason for repair. Packing peanuts in the box, good heavy bag. Got it wrapped up in some pig mat, keep it from making a mess. And they've got it capped off nicely as well. So fantastic job getting it to us. We're going to take a brief look at it here at the parts counter. Alright, so this is kind of second generation Stanadyne pump technology. Being a newer design, you can see the traditional style governor assembly is gone, and we've got some electrical connectors on this pump. DE style pump, diesel electronic, right? This is a DE2435-5805. DE, so electronically governed, 2-roller, 4-cylinder. The 35 is 350 thousandths diameter pumping elements, and dash 5805 is the calibration specification and bill of materials for this specific unit. Also known as John Deere part number RE518166. DE family of pumps, covering a range of about 50 to 200 horsepower, and this particular unit is capable of delivering 900 bar, which is about 13,000 psi, and this was the technology that Stanadyne went to become compliant with Tier 3 emissions regulations. So this is a generation newer technology than we've currently covered on our channel, so we're kind of excited to get into a newer style pump platform, bring you guys some content on the repair and rebuilding process of these pumps. Part count is greatly reduced in these pumps. These are considerably easier to build than their mechanically governed counterparts because they are computer controlled. Yeah, there's a little bit more technology happening here, but the rest of the mechanical governor has been eliminated, and this is considerably more simple in design, lesser part count, easier to build, and a pretty robust pump. Fuel inlet, fuel return here. This is the port for checking the timing. Inlet fuel temperature sensor. This is fueling solenoid, electrical connector for that. Injector line discharge ports and drive shaft. So this is where we're connecting to the engine. Tapered here, timing gear inside the timing cover of the engine, and a nut goes on to lock it to the engine. Fairly simple. You can go over to Clint's channel and you can watch an excellent video documenting proper removal and replacement. That's one thing we don't get to hit on too much at Area Diesel because we do the bench work. Clinton and those guys do the shop work, right? So they'll show you exactly how to remove this pump properly, how to time it to the engine, and how to go back together correctly. High quality work taking place over there. If you haven't already, go check them out. Tell them we sent you. The complaint again on Clint's pump. This thing started as a leaker, pretty evident, right? Classical case of schmoo, if you will. This thing actually went on, so it started as a leaker, and then it went on to making oil. So in the bottom of the pump housing casting, right here, you'll see a weephole. That is pretty classic where they leak at. And then the second, when they start making oil, now it's leaking oil out the front. We earlier mentioned diesel electronic, but what they should have named it, or what that should stand for, is drive shaft eater. Again, #1 failure mode is leak on these pumps, and they eat drive shafts. So we don't know what Clint's drive shaft looks like yet, but if it's like most of them that we see, the seal has worn away a significant amount of material on the drive shaft. There's actually 2 seals up in the front of this pump. One seal, right, regular old drive-in lip seal. One seal is keeping fuel inside the pump, and the other one over here behind the bearing keeping outside stuff and engine oil from coming into the pump. The weephole that we spoke of lives between the 2 seals, so when the inner seal fails after eating away at the drive shaft material, fuel will bypass it and come in contact with the weephole. You'll develop an external leak. If that continues, or if the other seal fails, what will happen is fuel will not only get to the weephole, it'll get out past the second seal and it'll pump fuel into the timing cover through the front of the pumps. They usually start as external leakers, and if not taken care of, they'll continue to go on to start making oil. That's where we're at with this one, leaking and making oil. If you're looking for content regarding the older mechanical governed style Stanadyne injection pumps, we'll drop you a couple of links. We've done some videos on those pumps before. One in particular for another piece of equipment for the guys at CNC. We've already got pretty good detail on how to go through mechanically governed Stanadyne pumps. Again, this particular unit electronically governed. Relatively popular style pump for us at Area Diesel Service. Clinton reached out. We actually had this particular pump in stock as an exchange, ready to go. We also stock brand new authentic OEM Stanadyne pumps on the shelf, first fit, tier 1 quality, but neither of those would make very good content. For Clint, he had a little bit of time. We decided we'd go into his. As long as she is rebuildable, that's what we're going to do. We're going to get this thing back to Corey. He's our resident Stanadyne injection pump expert, and we're going to follow him through the process of rebuilding this injection pump. We'll take you to Corey, and when he gets done, we'll meet you back here at the parts counter.
Okay everybody, it's Corey again. We got this DE pump for CNC. Obviously you guys saw what it looked like beforehand, so I got it all just blasted and cleaned up a little bit. Obviously you can see it looks somewhat better, but didn't worry about this too much because one thing I noticed right off the bat was on the front here, there's a little tab right here, and on this side it's broke off. Instantly, I'm going to replace this piece here whenever I go to rebuild it, because if that connector were to be loose in there, then obviously it could cause, intermittent running and things like that. It might cut out. So that's honestly real important for both those little tabs to be on there, just so it holds that connector and they're good. Other than that, I don't see anything on the outside that really strikes me, but we will get into it and see if I find anything too drastic. So with these, it's not a ton different than my other Stanadyne pumps, you know, I just kind of go through it, top down, front back, whatever. These don't have a lot of these, like, you know, this is your inlet return. These are just kind of fittings that help the pump run, so I don't have a lot of things to really take apart per se. This is your transfer pressure regulator, similar to a regular DBG pump, where, you know, this would normally be the inlet on those, where on this they have a separate inlet. I'll just start with this connector here. Once I get this pulled off, I'll explain this connector a little bit too. This connector here, right in this spot in these, on the back side where your plugs go into, basically underneath this plastic there's a solid copper plate, or at least it's probably split in the middle, just like you have your positive and your negative. Regardless, so these little pieces here sit on your studs, which is where your power goes through. Also, these little plugs here have this little brass insert, which kind of helps with the connectivity of the whole plate aspect of it. So that way it has a good connection between the back of the plate and your terminals, because if that's broke, if these get broke or if these get loose, then it could cause, again, an intermittent running because it's not getting a good connection, basically. A lot of this is just excess grease, but like I said, I'm going to replace this anyway because that little tabs broke off. So these just, sometimes the tops of these break off, but not generally. Here's an O-ring right here. Okay, so I'll take these out, which, as you can kind of see as well, they have these little plastic insulators so that way it doesn't ground out on the outside of this cover here, because this is like a anodized aluminum. So, you know, this is how it sits inside the cover there. So you have your two insulators and an O-ring, and then you have the screws which screw actually into the solenoid itself. That's how it gets power through here and through into the solenoid without it shorting out, basically. I'm going to leave that alone for right now because I'll have to spin this solenoid loose before I take this cover loose, otherwise I won't be able to get the solenoid out. So, you know, this is your main fueling solenoid, so that controls your whole pumping action, basically, of when it pumps and when it doesn't. This is your just temperature sensor right here, so it just tells the fluid temperature of the pump. It's your return connector. There's a little spring inside of here. So as it, you know, builds up pressure in the pump, it just helps regulate your housing pressure is really all it does. You don't have to worry about those ones getting plugged up as bad because obviously there's no flex ring or anything like that inside these pumps. Inside your inlet here there's a little screen that just comes out, maybe, there it goes. So it's just a little bowl screen. Helps catch any, I mean, ultimately it's basically just a rock catcher, you know, just helps filter out some of the stuff. Then inside of here there's another plastic piece, and you have to use, some might say that's just a brass rod, which really all it is, but technically this is a Stanadyne tool. It's in my Stanadyne book, so, but ultimately it's just a brass rod that's bent. So that little plastic piece is in there. I think basically it's just a stopper for that spring and that filter to sit on. Pull the regulator out. And this is where it regulates all your transfer pressure in the pump. Normally on a DBG pump, you know, this is where your inlet would be, so fuel would go in this way and then through your regulator and then into your supply pump. But for some reason on these, I decided to do it a little differently. Of course, that just has a regular orifice plate like any other one. Of course, you know, you got your regulating spring and your piston. Of course, that's worn out like normal. 2 O-rings on here. One thing that's a little bit different with these is it also has a little screen right here. Sometimes that will pop out. This one stayed in there. But again, it's just kind of like a secondary screen just to keep stuff from getting in through the rest of the pump. And I think it helps from getting particles inside of here to either jam up that piston or wear it out prematurely. That's just a plug, because underneath here is your vent screw. Okay, and this is pretty normal for a DE pump. So this is your vent screw, which helps regulate your return flow throughout the pump. So there are different numbers of these. It's 0 through 5. So a 0 lets the most amount through, a number 5 lets the least amount through, which is the wire size that goes through the middle of this. However, on DEs, like this one, that wire has broke out, which is very common for a DE pump. So then, you know, your return goes even higher because there's no restriction there. At least there's a lot less restriction. I think what happens is, for some reason these pumps have just the way the fluid runs through it. I think that wire, just from how these things wear, that wire spins around constantly instead of just kind of going up and down, and eventually it just spins so much that the wire just snaps and then it pops out. So out of 10 pumps, I have to replace probably 9 of them, of these. So it's super common for that to happen. I think more or less it's just a design flaw. This here is just a plug. There's really nothing underneath of it. But I have to take that out because I'm going to put my transfer pressure tap in this hole later on whenever I go to run it. So here's the plug where your timing pin would go into to time the pump. So normally there's always 2 O-rings on these. These ones here that have these Allens are usually pretty tight. Luckily so far the pump looks pretty clean. These have holes through them, it just helps the fluid go through them, through the whole rest of the pump. Because like on these pumps here, I don't know how much Kurt explained to begin, but you know, there's no advance on these, there's no weights, there's no governor actions. It's basically just an on-off solenoid and transfer pressure. It's really all that operates it. They're a lot different than any other Stanadyne pump. There's your cam pin, so that goes through your pump and into the cam ring. This screw here holds your transfer pump, keeps it from spinning inside the pump. Otherwise it wouldn't make any transfer pressure. Here's a little locking plate for the solenoid so it doesn't spin by itself. Just a spanner wrench for the solenoid, and you want to break this loose for taking this cover off, otherwise you'd never get it loose. Or you'd have to grab onto it with vice grips or something, and that's not good. So that's pretty tight. I'll explain more, because that's actually a set dimension in there, so I'll explain that more whenever I go to build the pump. Now we can take these screws loose. There's 4 screws in here with a little bitty gasket on them. Okay, so those come out easy. And I'll just use my screwdriver to pop this cover off. That's just a cover, because that's where your armature sits. So your armature sits in here, like that. Which, this doesn't move side to side any, it just moves up and down. which this is an old style armature, which is neither here nor there because I replace those every single time because they get worn out. They wear on the sides and they wear on the end where it hits the poppet valve, wears on the top, so it's just a wear part. Now, okay, so I can turn that by hand, which is good. I'm going to leave that in there for now until I get the head out. So basically the last thing I got to take out is that last head locating screw. Hit it with a punch a couple times. Hopefully it'll come out smooth. Oh yeah. There's 2 O-rings in here. There it goes. Okay. So basically that's everything on the outside of the pump. If for some reason you didn't take that vent screw out of there, and sometimes they can stick up a little bit, not always, but if you forget it, or if you take it loose and you forget to actually pull it out, and then you go to push this head out, it'll ruin the inside of the housing. So that's probably a main thing to watch out for. But let's see if this will turn. Okay, it moved a little bit. Okay, there we go. Okay. There's that. You have your pumping plungers that were sitting on your rotor here, just like any other Stanadyne pump. You have your rollers. These are like ceramic rollers. Not really much difference to them, just a different material. I don't really know why they decided to put ceramic rollers in these. Push this out. So it's your cam ring, like any other Stanadyne cam. So that cam screw fits right into there. Normally though, these don't wear out. Yeah, like that one looks perfect. So basically now we have the drive shaft. This here is your transfer pump. This is your inlet hole, so fuel is going in. That's the hole for that screw that went into the bottom here to keep it from spinning. And then that's where your last bolt went in. One of these side bolts, this guy right here. So that screws into there. That's kind of a rundown of kind of how this is set up. So fuel in, basically then fuel out. Clip off of here. Just a retaining clip. That's just another retaining ring. We have our little roll pin here, come in handy. Okay, roll pin comes out. Nice little container. There's what, 7 screws there that you gotta take out. There's no gaskets or O-rings on any of these screws. There are an O-ring on each one of these plates, which a lot of times they're broke, so we'll see if these ones are still intact or not. This here is a little retaining plate which sits on top of here, helps hold this O-ring in, which, as we can see, is snapped. It's very common with DEs, those O-rings break. I don't know if it's just the suction force coming from the supply pump is what breaks them. I really haven't figured out why, but a lot of them are broke. Here's your liner and blades, or vanes. It's just a vane style pump, and then this plastic band just helps hold the vanes out against the liner. Contrary to other DB Stanadyne pumps, these liners and blades don't wear out as often. Like these ones look fine. some reason DE pumps don't wear out their liner and blades very often. However, this spring band is worn out. I don't know if you'll be able to see it, but it gets little flat spots right here where all these blades run at, and whenever they get a flat spot, this gets weaker, but also it creates less pressure holding the vanes out. So that's another replacing part. That's fairly common for those to wear out. Here's your center part. So this actually, it came with a little retaining plate down below. So this is what actually drives the vanes. So this little key sits inside your drive shaft. This sits on the key because there's a little keyway slot right there. And your drive shaft is turning this part, but the outer part, the liner part, is stationary. So this part, spins inside of here, creating your transfer pressure. Again, those don't really wear out. We replace this key every single time because it gets wear on the sides. So this slides off, and this O-ring here is also split. Yep. Kind of hard to call it an O-ring whenever it's straight. That has a little bearing there to help that, just to help kind of support that drive shaft. So there's your drive shaft. It's a little bit different than the one that Kurt showed you before. However, this is that wear pattern here, so that shaft there needs some attention. But I got other shafts. I'll grab one of the other ones so that way, I don't have to wait on the machine shop to cut that down. I should have one of these shafts. Basically, there's only like 2 different style number drive shafts for DEs, depending on whether it's like a 4-cylinder or 6-cylinder. Mainly, I think, because of this timing groove right here. So this groove right here is where your timing pin goes in through the top of your pump. So this plug here, this lines up, and then once that notch lines up with that hole, that's where the timing pin goes in, then your pump is in time. Little Stanadyne timing pin, and this will go through your pump here. Has a little handle on it, and then that is the exact fit for this slot. So basically, normally I stick it in there and then roll it over, and then voila, it's in time. So yeah, they're a lot more forgiving in the timing aspect. So basically, as long as you have your dot on the rotor here lined up with the dot on the inside and you stick your timing pin in, voila, you're timed. There's no internal timing marks, there's no air timing, nothing. That's honestly a lot easier on these pumps. Now we can take the solenoid off. This just has 2 O-rings here. Okay, so this solenoid here, kind of an unusual failure in a sense, because a lot of times they'll wear out on the top, which this one has some wear. This is an old solenoid too, because it has a square box right here. Normally they're just round, but on either side here there's a little basically burnout spots kind of, and that's a common failure with these. It's actually cracked in 4 spots, which I don't see as often, so that solenoid there is definitely getting replaced. So this is just a retaining plate. This is basically what those 4 bolts screwed into. This goes in the bottom here. 4 bolts screwed in through there into this. And then that puts pressure on this little guy right here. So this is like a little, just a holder plate for this, which is a crush washer. You're supposed to set that solenoid to a certain dimension, because then that gives that a certain amount of crush. And once you crush it once, that's it. You can't reuse it. At least you're not supposed to reuse it. You're supposed to, which they come with new ones in the gasket kits. So only time you're really ever going to take that out and put it back in is whether you're out in the field and you want to switch out the solenoid, which you really shouldn't do. Or if for some reason I was running it on the stand and I thought that this solenoid went bad and I had to switch it out. So this here is the poppet valve. So this is what the armature is pressing against. As your solenoid operates, turns on and off, basically it presses on that poppet valve. So this springs, and basically this armature is pushing up and down on that. So this armature is going up and down thousands and thousands of times while it operates. Because every time it pumps, for each individual cylinder, that thing is going up and down. So for every revolution, this goes up and down 4 times. So that's why that wears out, and that's why they switched it to a different material to help with the wear. These poppet valves don't normally wear out. Every once in a while I replace them. So this plate has 2 little half moons, kind of like a normal Stanadyne pump. They're just a little bit different shape. Rotor comes out, so those just get thrown in there. Then there's 2 little pins here that those half moons sit on. Basically just use this little container here so I don't lose some of these small parts. So there's a spring there, which what the poppet valve operates on, and then there's these 2 little shims. So those shims basically just help determine your spring tension in a sense. Basically that's all that's left in the rotor, which the rotor looks good. DE heads don't normally wear out as much as other Stanadyne pumps. And then basically all I got left is these 2 accumulator pistons, which again, there's springs inside here, and normally these springs are broke. Which is why I come with new ones in the kit. They also come in totally different styles. Yeah, so these ones are broke. Okay. So basically it goes, the pistons here go in first, and then it would be this spring goes on one side and then this spring goes on the other, which as you can see, that spring is snapped in half, which is common for DE pumps and their accumulator pistons. So that's why they went with a totally different design, which I'll show you again whenever I go to rebuild it. That's very common with DE pumps, which basically once those break, then your accumulator pistons help with your high speed fuel. So as you're revving up higher and higher and higher, those accumulator pistons help provide extra pressure to help fuel the rotor, so that way you don't get a drop off in horsepower basically. It's kind of what they do. The last thing with this is there are technically snubber valves in here, which I don't ever mess with. I've never really felt the need because I haven't found that they fail regularly. So normally I don't mess with those. And it's one of those, if it ain't broke, you know, don't fix it. Now I just got to take the seal out, puller right here. I know Kurt probably explained a little bit of how these seals work before, but I will pull them out, hopefully, and show you how they go in. This is just a seal puller made specifically for these. I pulled the outer seal and the bearing out to start with, which I know that he was complaining originally that it was leaking fuel out the weephole, which it does look pretty wet in there. And that's a common problem with these pumps. So eventually they just leak out the weephole or into your engine oil, one of the two. Okay. So now there's nothing left in there. Okay. Your fuel seal. This would be your oil seal and then your bearing. So it kind of stacks up like that in there, and actually there's a gap in there like that. So oil seal goes in first, well, fuel seal keeps fuel into the pump, then your oil seal keeps oil into your engine, out of the pump, and then your bearing, which just helps support the shaft. Again, these come in the kit, so I don't really worry about any of that stuff. But most of the time they're worn out anyway, so they need replaced. So it's basically whole teardown process of a DE. So I'll go get this cleaned up and come back, and then we'll rebuild it and run it on the stand.
Oh yeah.
Okay, so I got everything cleaned up here. Everything looks good. Everything cleaned up good. Luckily, the pump was actually clean. Didn't have any fuel contamination in it. So basically, I got everything laid out. I got all my new parts in the box here. So basically, where I'm going to kind of start off at is I will put the new seals in the housing. So also I got this is my seal installer, so you know it has different dimensions so the seals go in the correct way basically. So we will go out and I will put these seals in with the arbor press. Okay, so I got my housing here, got in the arbor press, got my tool here. The metal inner seal goes in first. Like I said, this tool has determined distances so these seals get installed to the right depth. Put a little bit of grease on the outer oil seal just to help it slide in. Kind of pre-start it to make sure it actually goes in straight. That's pretty good. And then the new bearing. Like I said, all this comes in the gasket kit, so I didn't have to special order anything. Okay. Basically now all there is to it. And we got newly installed seals. Okay, so I got back here in the room, got my housing mounted. I'm just going to start with the drive shaft. That's basically the first thing that kind of goes in, which also means I got to build my transfer pump onto the drive shaft. So the bearing plate goes on first. I'm actually just gonna, I always kind of pack this bearing with some grease. Whether or not it really needs it, I'm not sure, but I figured a little extra grease won't hurt. Put some new O-rings in these grooves. I just put some grease on there just to hold this little retaining plate. Okay. Goes on there first. Then my key goes in this slot. Like I said, this is a brand new key. Some grease on there to hold it in. Now my vane holder. There we go. That slides on there. Our transfer pump liner, which just has to go on the correct direction. Okay. Got a brand new spring band since that one was worn out. So this one has no flat spots on it basically. And with these blades you want to, is on the back of these you can see where it's riding on that spring band. You want to put it in basically the same way that it came out. So because that's how it's been wearing on the liner. So last one, there we go. Last one is always a little hard just because that spring band's really pushing on it. Now, put on the last plate with the new O-ring. Okay. Put my screws back in here. Then I have to use, I guess, a couple different tools that you haven't seen before. Just gotta pre-start these. These have to be tightened down in a star pattern. Okay, so one of the first tools is this guy. Basically a band clamp in a sense. I guess kind of similar. to a piston ring clamp. That's how you put your pistons in your cylinders. But basically what this does, this clamps on here and it lines these 3 plates up, because if these are even off a little bit, they will not go in that housing. So hopefully once I tighten it up. Also, this is my torque wrench. So hold this tight. I just kind of pre-tighten them first, and then I go back and actually torque them in. Okay. Obviously, if that's too tight, then it could seize up your transfer pump. That actually feels pretty good, so that should work. Now, I have my little container here. I can dump it out. This is a roll pin installer. Has these different grooves on here to do your different dimensions of how far in that roll pin has to go. Okay, just like that. Got our retaining plate, and we have our clip, our snap ring. Okay, so now that is rebuilt, and it's pretty stiff, which is really how it should be with that new spring band. And my seal sleeve basically is screws on the threads, drive shaft. I'll normally put a little bit of grease on it. Now, basically you want to kind of line up your holes, you know, from how they're going to go in. Just try and make it a little bit easier on yourself. There it went. Okay, so that's in there. Take my bottom screw. This also just helps kind of align it for starts. Let's keep it finger tight for now. Put our plastic piece in there first. Get O-rings on here, put a little bit of grease on them. And with these, you gotta push it down in there to get those O-rings to seat, which that just did right there. Now we got our spring and our filter for screen. New O-ring on her inlet fitting. Okay, so now since I got that in, I'll put this in as well before I tighten that bottom plug. And this just makes sure that everything's lined up, which it feels good. I do torque this in. This because I don't really ever feel like over tightening it, since it could mess up those threads. Bottom screw now, I don't really worry about it as much. Okay. So now basically the transfer pump is done in the drive shaft. Return connector here. I also just make sure that that little spring in there is free, and I did blow through it earlier just to make sure there's no piece of junk in there, because you can't really see through it. We got our regulator here, brand new piston. I actually got a new spring because his original spring had some wear to it that I didn't like. So as a precaution, I decided to change it. Because if that spring breaks in there, that is going to lead to some major problems. Just preset that like any other Stanadyne pump. New O-rings on here. Grease. Tighten that. Don't tighten that too hard, otherwise you could snap that off. Gotta put this plug in here, because if you don't, then fuel is gonna go everywhere. Now we'll put in our temperature sensor, since it's also easy to put in. So now we will put in our cam ring. Of course, it has an arrow on it, just like any other Stanadyne pump. Depending on what rotation it is, you know, you got to make sure you're putting it in the right way. Which that would be correct. Already double checked earlier to make sure none of the lobes had any chips out of them or anything like that. So that's all good. Halfway line that up. Got our cam pin here. And I will torque this in. This gets torqued in with a foot-pound wrench. Okay, that's tight. Pretty well it for this right now until I get the head in. So I'm going to flip this over. I'm going to line up where my shoes are going to go with the furthest point out on the cam lobes, just because it'll make it easier to put the head in. A little bit of calibration fluid on these. Make sure they're free, which they are. I'm not going to put the O-ring on it right now. What I will do is put my new accumulators in here. Like I said, come in the kit. So we got one piston here. Got our other piston. I was talking about earlier, they revised these springs, so now instead of there being that spring there and this heavy spring, they went with two springs, so an outer spring and an inner spring. Partially they did it because I think these ones don't break as easy, and also it is easier for us technicians or anyone out in the field to go, well, which side does the heavy spring go and which side does the light spring go? So they're just revised it and made them both the same. Put our new springs in here, new little top caps. Sometimes whenever the spring breaks, it can jam up in there and actually break those little top caps. I've seen those broke plenty of times. But our screws. That's tight. Now we got this, the rotor. I just kind of give it a little bit of lube there. Make sure that it's actually nice and smooth in there, which it is. So now, before I stick it in there, I'm going to put my two small shims in here. Don't really matter which one goes in first. And then I'm going to put my spring in here. I'm also going to inspect this spring, which it looks good. And now my pop-up valve. Now with this pop-up valve, there's a slot on the bottom here, and there is a pin inside of this rotor to where that slot hooks onto. So if for some reason you were to stick this in here, and you're like, oh, that's good, and you didn't have it engaged on that pin, once you tighten down your armature, you snap it. And you might mash the bottom of that pop-up valve, and it might not operate at all. So it's real important that that actually lines up, and it actually springs now too. So that's kind of a dead giveaway. That is correct. Okay, that's better. Now stick our little pins in the head. These are what those retaining plates stick on. Okay, those are in there. That looks good. Now stick one plate in, stick the other plate in. Okay, So now I got my half moon plates in here on these little pins. Pop valve is in there and it springs, and now the rotor won't fall out because the half moon plates are holding it in. And that's why I have this, so you can set the head on there. Okay. Got our little keeper here for the new crush washer. So I don't know if you can tell, it's kind of hard to tell, but this being a new one isn't crushed like this old one is. So got that on there, so that's gonna stay there for a second. Got a brand new solenoid here, and we have our brand new armature. So like I said, this armature is made out of a different material. It's just a more wear resistant material than the old one. Put our O-rings on this. O-ring here, an O-ring at the bottom. A little grease on the top one. Okay. That's it. I like to put my armature in this first, to make sure that's actually in there correct instead of being in there crooked. Put it in there first, and then stick it together. Good way to tell if that's actually in there correct is, I don't know if you can hear it, but if you shake it, you can hear that armature rattling in there. So that's how you know that it's not bound up or anything. Now just line up the holes. Grab our 4 screws here with our new gaskets. And now our plate on the bottom goes in there, and you can kind of see how it went in the last time, how it came out. As you can see where it is wearing on that crush washer. Let's just put in how it came out, and these screws here will also get torqued in. So yeah, if you were to put that together and you tighten it down and that armature quit moving, well, you know you did something wrong. Because that has to move. Put some grease on the bottom O-ring. Basically, I'm just kind of getting it hand tight for now, because that has to be set to a certain dimension. So we got the tool and the fixture here, and basically all this dial indicator does, it goes on the end of the rotor, so it's just reading how far this is moving. So, and that dimension is determined by how much crush you put on that crush washer by screwing in the solenoid. So that has to, if it was a brand new head and rotor and a brand new poppet valve, it's one dimension, and if it's a used head and rotor with a used poppet valve, it's another dimension. So they give the used one a little bit more room, free play, probably because they assume that the brand new one's going to wear in and give it about the same amount. A little bit more. If it's too far out, then your poppet valve is going to have too much movement, so your spill opening is going to be larger. You know, your poppet valve will stick further out of the rotor. Where again, if it's too tight, then it might not stick out enough and it might not spill correctly. So if it's too far out, it might spill too much, or it might not actually close, so it might not pump at all. Or if it's too tight, then it might always pump and it might not ever shut off, or it might not spill enough, so your delivery might be incorrect. So now, since that's set, I can actually go ahead and put my O-ring on here, put some grease on it, and put my plungers in here. O-ring on here. My little plungers on here. Grease on the O-ring. Also like to put some grease in here. Now, just like any other Stanadyne pump, you gotta line up the dot with the dot. Also gotta turn the head to make sure that faces towards me. This is where it can be kind of a pain, because, oh, and see, there we got lucky. Sometimes these heads can be a real pain to get lined up. Of course, always put in the bottom bolt first. These other two head bolts, it doesn't really matter which one you put in first. Normally I just like to put them all in first before I torque any of them down, just to make sure that it's all lined up. So now we're getting pretty close to being done. I have a brand new vent screw because the other one, the wire had come out. So as you can see, there's a little wire in there, and that's what actually restricts your return fuel. Put that in there. Put a plug in there. So far I found that the DE kit, gasket kit, is the only one that you will use every single O-ring and gasket out of it. All the other kits, I think, are just kind of a generic kit, so they have some other O-rings that will work with other pumps, but with the DE, it's every single O-ring and gaskets used. This plug here normally would go here, but I'm going to leave that out because I need that for the test stand. Same way with this plug. I'm going to leave it out for now until I put all my brackets on there to run it, and then I'll put it in. Put my studs in there. These studs also get torqued in because I don't want to over tighten them and either strip them out or break them. Either way would be bad. O-ring on here. Put some grease on the inside of our new cover, just so that it doesn't break the O-ring. O-rings on our little plugs here. Sometimes these can be kind of a pain to get started as well. And basically the last thing I got for now is this little locking plate for the solenoid, which goes on this other side. Just down to stamping it, and then it'll be ready to run. So that is a rebuilt DE pump. So now I'll pull it off of here, get all my adapters and stuff like that, and then we'll go to the test stand. Okay, so I got everything hooked up. I got our brackets hooked up here with my tone wheel and everything, which I'll explain a little bit more of that whenever I take it back off. I timed it with the pin, and there's also another notch in here that you have to kind of line up at the same time, which, like I said, I'll explain that later. But we got everything hooked up. This is actually a different machine than what you guys have seen before, so This is our ABM machine by Hartridge. Pretty similar but different. Same, you know, I can still basically do everything on this thing that I can on the other one. It's just different manufacturer. On DE pumps, I have to have this secondary laptop and box, which basically runs the pump. So I have a cable that goes from the laptop to this box, and then this main harness goes to my solenoid, and it goes to the temperature sensor, and then it goes to basically my speed sensor. It's basically a tone wheel, so it picks up every single time it goes around. That's kind of how then it tells me what all it's doing here. Stan is just telling me fuel delivery, transfer pressure, return, and RPMs. It's more or less ran by this rather than this. So that's kind of how they're a little different. So that's also why you can't just throw these things together, because they're not necessarily set, because this isn't really setting anything, it's more or less just checking it, but it's more sophisticated in that aspect to where, you know, you can't spin it with a drill and see if it works, because that's just not how these things work. So I'm going to start this thing up, and I already got it warmed up, just so you know, we're not just standing here watching it warm up. I'll get her going, and got to type in some information here before I start. Basically, this has all the different pump numbers, so then it has its own internal specs that it double checks to make sure that the pump is actually functioning in the parameters that the factory has, you know, specified in. We'll get this going. So first it checks to make sure that it's actually going to close correctly. So far I haven't done anything to the pump, I've just warmed it up basically. And basically this laptop is telling me what steps to check, because the only thing I ever set on these is the transfer pressure. So it's just telling me what to look for, and is it in spec? Yes it is, or no it's not, I need to adjust it, stuff like that. Okay, so currently my transfer pressure is too high, so I got to pull this plug out and then adjust it. Checks to see your injection timing basically. So this is just a preliminary fuel check just to make sure it's close to being in spec, which is fine. Right there is checking to make sure that the solenoid actually shuts it off and quits pumping. So on this particular pump, it needs 100 cc's of cranking, basically, which is what I'm running right now. So it's averaging 123.5. So we have basically 24 cc's of extra fuel that, you know, is on top of what is the minimum requirement. So that's good. Now we're starting to get into the main fuel delivery checks. Okay, so that's basically all the specs that this pump requires. It passed all of them just fine. All the fuel's deliveries are about in the middle of the specs, so that's good. I did not see any drips coming out of the weephole, so he shouldn't have any problem with fuel leakage or fuel getting into the oil. Overall, the pump ran great. We fixed all the bad parts that were in the pump when we rebuilt it. So basically now I just got to take it back off, and then I'll just take all my brackets and stuff and I'll roughly time it and then clean it up and send it back. Okay, so I got the pump back in the room. I basically just took my inlet and my return off. This just holds my speed sensor here, and it also has this little pointer here. This is a tone wheel, so you can see these points here, and that's what goes against your speed sensor. So every time it, you know, goes past there, it creates a electric shock, you know, how speed sensors work. Whenever I put this on, there's this notch right here. So this pin goes into this notch, like that. And then that is also when your timing pin lines up with the notch in your drive shaft. So basically, whenever I put it on, turn this to where this fit in, and then lined it up here to where, okay, that's where my pin lines in, and then I tightened it down onto the drive shaft. So that's how then the pump knows that the drive is in time with the pump, where otherwise it might actually change how the pump runs on the stand because it's not in time with even with itself. So that's kind of the biggest thing that I really wanted to explain. But it's also like then whenever now, you know, I'll leave that in there. I'll pull this drive adapter off, I'll pull the hub off and everything else. Then whenever he gets it back, you know, the pump will still be roughly in time. You know, I would still suggest him to put a pin in just to make sure, but overall it's at least going to be close, because these drive shafts are stiff enough to where it's not just going to free spin on its own. So yeah, basically now I'll just pull all this stuff off and cap it up, and there's no timing mark that I got to put on the flange or anything like that. I said I'll just clean it up and send it back to him and he can throw it on his engine. That's basically all we got for it.
Here you have it. One Stanadyne DE injection pump. Cleaned up, disassembled, inspected, repaired, rebuilt, calibrated, and back at the parts counter for another cycle of life. We followed along, watched Corey completely go through this pump, talk about the particulars and what he found. He is an absolute expert when it comes to these Stanadyne DE pumps, or any Stanadyne pump for that matter. What did we find? As suspected, you know, we kind of joked when we opened this video up, DE pump should stand for drive shaft eater, right? So we'll bring you in close and we'll show you the wear on this drive shaft. This drive shaft goes in this pump in this orientation. and you can see two areas of wear, right? The internal seal worse than the external. The weephole lives between them, so when they start leaking fuel externally, it's the first seal, and when they start making oil, leaking it into the timing cover, it's the second seal. As suspected, another drive shaft eaten by a DE pump. No big deal, we've seen that before. Other things, fueling solenoid was bad and got replaced. A couple of cracks in the plastic and a little bit of erosion, fuel erosion wear on it. Also, no big deal. Standard wear items, gasket kit and seals, standard issue stuff there. Accumulator spring was broken, pretty common failure mode as well. Just a general going through as far as that goes. So went together wonderfully, calibrated perfectly. Everything is back in tip-top shape. All right, so the $1 million question, we get it every time. What did this service cost? This pump at today's prices and with the particular repairs done to this unit totaled up to $1,371. Shop around, take a look at these, and what you'll find out there, probably about half of what the OEM gets for a remanufactured unit and about a third of what they get for a new unit. Pretty cost-effective alternative, and we'll take the Pepsi challenge with them any day of the week as far as quality goes. So again, if you didn't come to us from Clinton's channel, CNC Equipment, be sure to go over there and let them know that we sent you. They have a fantastic video demonstrating the official and proper removal and replacement of this pump. They also executed a perfect shipment to Area Diesel. Always a reminder, if you're going to send something our way, please pack it up so we don't experience any more damage in the shipping process. He'll show you how to take it off, how to pack it up, how to reinstall it, and bring this machine back to life. Alright, if you haven't already subscribed to our channel, please do so. We are on the brink of a 10,000 subscriber milestone, and we're going to be doing another subscriber giveaways. Please hit that subscribe button and stay tuned for a giveaway soon. Many of you who have been following along have expressed the desire to support us, but you don't have the need for an injection pump overhaul or a turbo rebuild or whatever other parts that we distribute at Area Diesel. We have received a bunch of requests to start a merch store where folks that enjoy our content or like when we collaborate and help out other YouTubers, they would like an opportunity to support us. So we have started a merch store. We're in the infancy. Today we've got 2 hats on our merch store. Nice, high quality, fitted flex hats. So if you're in the market for a ball cap, go over there and check them out. We've got them in stock. All right, if you find yourself in need of something we can help you with, please don't hesitate to let us know. You can call us at 800-637-2658. You can email us at parts@areadiesel.com, or you can log on to our website at areadieselservice.com, where you'll find a large amount of high quality information and the ability to chat instantly with a diesel engine expert through the button in the bottom right hand corner of your screen, or you can stop by any of our locations in Iowa, Illinois, or Indiana. So that's it. Thanks for watching.